Imagine holding a single ancient tooth in your hand and realizing that tiny piece of history could unlock these profound secrets about an entire civilization, maybe changing everything we thought we knew. Today, we're diving into a story that does exactly that, thanks to some pretty amazing science. Our deep dive today is into the first complete ancient Egyptian human genome ever sequenced. We're talking the full genetic blueprint. We'll unpack the incredible findings from some groundbreaking research focusing on this one man who lived almost 5,000 years ago. Our mission, to understand not just who he was, but what his DNA tells us about, how people moved around, cultural exchange, and the actual roots of one of the longest lasting civilizations ever.
And to do that, yeah, we're drawing on brand new research. It's published in Nature called Ancient Egyptian Genome, Fertile Crescent Ancestry Revealed. We're also pulling insights from ancient Egyptian potters' life and legacy, and of course, the core scientific paper itself, which gets really deep into the data. It's this great combination of genetics, archaeology, osteology, all painting this, well, really rich picture.
Okay, so let's start with the breakthrough, because this is huge, right? For decades, researchers, even Nobel Prize winner Svante Pääbo, they kept trying to get ancient DNA from Egyptian mummies, from remains, and they just couldn't get a complete sequence. The climate there, the warmth, it usually destroys DNA. So what was different this time? Why now?
It really is a remarkable achievement. After 40 years of trying, basically, new technology has finally cracked it, the first whole genome from that region. And his burial was key. He was put inside a ceramic pot, inside a rock-cut tomb. That created this kind of microenvironment that, well, surprisingly, helped preserve his DNA much better than usual. It was just this amazing bit of luck for science, really. Lets us peek back thousands of years.
Incredible luck. So who was this person, this unexpected window into the past? What do we actually know about him?
Well, the analysis shows he was an adult male, estimated to be middle-aged for his time, probably somewhere between 44 and 64 years old. The upper end of that range, 64, seems maybe most likely based on the wear and tear.
And when exactly did he live? What period are we talking about in Egypt's history?
He lived around 4,500 to 4,800 years ago, so that puts him right at this crucial overlap between the early dynastic and the Old Kingdom periods. This is the era they started building the first pyramids, just a few centuries after Egypt was unified. And his remains, they were found buried down in Nuwayrat. It's a village about 265 kilometers south of Cairo.
Wow. And the science gets so specific now, they could use his DNA, his bones, to predict what he might have looked like.
Yeah, it's pretty amazing. They estimated his height at around 157.4 to 160.5 centimeters. That's roughly, 5'2" to 5'3". And based on the genetic markers they found, the prediction is brown eyes, brown hair, and skin pigmentation somewhere in the range of dark to black skin.
It's fascinating how much his bones tell a story, just about his daily life. What did the osteological analysis, what did that show about his work?
Oh, it showed clear signs of really extensive physical labor. I mean, severe osteoarthritis in most of his joints, his vertebrae too. His teeth were heavily worn down. And interestingly, his seat bones were expanded, which often happens if you spend long periods sitting on hard surfaces.
Okay, sitting. What else?
Well, there was also evidence of repetitive arm movements, sort of back and forth, and arthritis in his right foot, which turned out to be quite significant.
So a life really etched into his skeleton. You can almost picture him working. What kind of job did the researchers think he might have had?
Based on all that wear and tear, they suggested he was likely a potter or maybe a similar craftsman like a basket weaver. It fits that pattern of sitting for long hours on the ground, legs and arms extended, head down.
And the foot arthritis, how does that fit in?
Well, that's possibly the clincher for the potter idea, the potter wheel. It was introduced to Egypt from the Fertile Crescent around 2500 BCE, so right in this time frame, and is often stabilized using one foot. That specific strain could absolutely explain the arthritis in his right foot. It just lines up very neatly.
That connection to the pottery wheel is pretty compelling. What about his diet? Did that match up with what we'd expect for someone in the Nile Valley back then?
It did, yeah. Pretty typical for Egyptians of that era. The isotope analysis showed he likely grew up right there in the Nile Valley's hot, dry climate. He ate an omnivorous diet, so terrestrial animal protein, plus plants like wheat and barley. There were some elevated nitrogen values, which could relate to the arid environment, maybe manured fields, or perhaps eating Nile fish.
Okay, but here's where his story takes a turn, right? This guy sounds like a working man, an artisan, yet his burial sounds almost high status. Placed in a ceramic pot inside a rock-cut tomb. That wasn't typical for a craftsman, was it?
No, not at all. It's a really intriguing contradiction. A burial like that was highly unusual for someone presumed to be, a laborer or artisan. The speculation is maybe he was just exceptionally good at his craft, like a master potter or weaver whose skill earned him some kind of advanced social status or favor from someone important. It suggests maybe a society where great skill could elevate your position, even allowing for such an uncommon burial.
It's a fascinating thought, and his story doesn't even end there, does it? His remains went on quite a journey after he died.
That's right. They were excavated way back in 1902 by John Garstang. They were actually donated by the Egyptian Antiquities Service, which was under British administration at the time. First went to the Liverpool Institute of Archaeology, then later transferred to the World Museum, Liverpool.
And then the Blitz happened.
Yeah, and this is just incredible. Those remains somehow survived the bombings during World War II. The Blitz destroyed most of the other human remains in the museum's collection, tragically. But Hint survived. Quite the survivor, even millennia later.
Wow, what a story just for the remains themselves. Okay, so we have this picture. Hardworking artisan, maybe a potter, surprisingly fancy burial, survives the Blitz. But the really revolutionary stuff, the history rewriting discoveries, they come from his DNA, right? What did that immediately show?
Well, first off, his closest genetic relatives, his strongest affinity, was to people living today in North Africa and West Asia. And interestingly, the analysis showed no signs of recent consanguinity, so no evidence his parents were closely related.
Okay, so immediate family history seems straightforward. But the deeper ancestry, the ancient roots revealed by his whole genome, that's where things get really interesting.
Exactly. The analysis basically broke down his ancestry into two main components. The biggest part, around 80%, traced back to ancient people who lived right there in North Africa. Specifically, they matched him closely to genomes from a Middle Neolithic site in Morocco, Sharat Rouazi, dated between about 4780 and 4230 BCE. So that tells us there's a really strong local North African Neolithic foundation for the people of Egypt during the early Dynastic and Old Kingdom periods.
80% local, that's significant, but what about the other 20%? Where did that come from? Any surprises there?
That's the big surprise, yeah. The remaining 20% of his ancestry wasn't local. It traced back to ancient individuals from the Fertile Crescent, particularly Mesopotamia, think modern-day Iraq, and specifically from Neolithic Mesopotamians living way back, maybe 9,000 to 8,000 BCE. There was also a smaller bit from the Neolithic or Chalcolithic Levant.
Okay, hold on. Mesopotamia, that far back. What does that mean for understanding ancient Egypt? This sounds huge.
It is huge if you connect it to the bigger picture. This finding is monumental because it's direct genetic evidence. It shows people actually moved from the Fertile Crescent into Egypt and mixed with the local populations around this time or leading up to it.
Why is having the genetic proof so crucial here? Didn't we suspect connections?
We did, but mostly through archaeology. We saw similarities in writing systems appearing, the pottery wheel like we discussed, domesticated animals, plants, all signs of cultural exchange with the Fertile Crescent. But this DNA evidence, it's definitive proof that it wasn't just ideas or goods traveling back and forth. People themselves were migrating. They were mixing. It really opens up the possibility that this whole wave of cultural and demographic expansion starting in Mesopotamia during the Neolithic reached both Egypt and Anatolia.
So it wasn't just trading pots. It was people moving, families mixing, actual gene flow. When do they think this migration, this gene flow from Mesopotamia happened?
Well, the genetics seem to support the idea that this gene flow started coinciding with Egypt adopting the Neolithic package to, farming domesticated animals. And that happened as early as the 6th millennium BCE.
And then the cultural exchange kept going, right?
Yeah.
Especially with Sumer and Mesopotamia booming later on.
Exactly. That continued through the 4th millennium BCE. You see things like the pottery wheel becoming common, early hieroglyphic writing appearing in Egypt. Both have links back to Mesopotamia. And the researchers suggest that maybe some of this trade and migration didn't just come overland through the Sinai. Perhaps routes through the Mediterranean and the Red Sea were important too, which could explain the specific genetic signature they found. It really paints a picture of a long process, millennia long, involving not just cultural borrowing, but actual migration and mixing.
That's fascinating. But it is important to remember, like the researchers point out, this is based on one person's genome.
Absolutely. That's a crucial caveat. We need many more ancient genomes from Egypt from this period and others to really grasp the full picture, the variation in ancestry across the population.
Right. And one other detail from his genome, you mentioned no sub-Saharan African ancestry was detected.
That's correct. Specifically, the Nuwayrat genome didn't show any substantial ancestry related to, say, a 4,500-year-old genome found in Moda, Ethiopia, or other ancient individuals analyzed from Central, Eastern, or Southern Africa. So for this specific individual, at this specific time, his ancestry profile points very clearly towards North Africa and the Fertile Crescent.
Okay, so this one genome gives us an incredible snapshot of his time. But how does it connect to the bigger genetic story of Egypt through history? What does it tell us about, say, later Egyptians or even Egyptians today?
Well, it extends the genetic record way back. Before this, most ancient Egyptian DNA data was from much later, like the Third Intermediate Period, around 787 to 524 BCE. And interestingly, by that later period, Egyptians showed a big increase in ancestry from the Levant, around 65% related to Bronze Age Levantines, though they still carried some ancestry from local groups related to our Nuwayrat man. This later Levantine influx, it might be linked to things like the Bronze Age Canaanite expansion, maybe the Hyksos rulers settling in Egypt. There are historical events that could explain that shift.
So the picture changes over time. And what about present-day Egyptians? Looking at them genetically, it's an even more complex tapestry, isn't it?
Oh, absolutely. Present-day Egyptians show really substantial genetic diversity. It's quite a mix. Modern Egyptians' ancestry, based on current modeling, seems to come from about 5 main sources. You've got groups related to our Nuwayrat man that ancestry ranges from maybe 32% up to nearly 75%. Then groups related to those middle Neolithic Moroccans making up anywhere from roughly 29% to 73%. Then the Bronze Age Levant contribution between about 12% and 57%. And then, importantly, you see ancestry related to that 4,500-year-old individual from Moda, Ethiopia, that's between 7% and 56%. And also ancestry related to much more recent individuals from Congo, maybe around 230 years old, contributing roughly 5% to 52%.
Wow, so those East and West African ancestries seem to have arrived much more recently in the mix for present-day Egyptians.
Exactly. That's what the current data indicates. It points to more recent connections and gene flow shaping the modern Egyptian genetic landscape.
It's really a fascinating look at how identity and ancestry evolve over millennia, isn't it? This one genome really helps reshape that understanding, showing just how dynamic and interconnected Egypt's history has been. So today we've taken a deep dive into the truly extraordinary journey of one ancient Egyptian man. How his single tooth, unlocked by modern science, revealed this incredibly complex tapestry of deep North African roots, mixed with ancient Fertile Crescent origins. We saw how his DNA provided that groundbreaking, direct genetic evidence for human migration, not just cultural exchange, stretching way back into the Neolithic.
And from that unexpected blend of ancestries to the, fascinating clues about his life as maybe a master potter who got this high-status burial, this whole deep dive just reminds you that history is often so much more nuanced, so much more interconnected and full of surprises than we might think.
Yeah, absolutely. So as you go about your day today, maybe take a moment to consider the incredible layers of history, migration, and mixing that reside within all of us. What unexpected connections might your own deep dive into ancestry reveal? And how might that change the story you thought you knew about yourself or about where we all come from?